Okay, this is Mr. Nichols. We're on interim test number 2, starting at number 8. So this question asks us, gives us a table, 2 boxes of paper are $14.50, 4 boxes of paper are $29, and 6 boxes of paper are $43.50. So in order to solve for our question, what is the cost of 1 box of paper, we decided that we should divide the total cost by the number of boxes. And we also noticed that this is a proportional relationship here. So every time we're going up 2 boxes of paper, we're going up $14.50. So if you add $14.50 to $14.50, you get $29. Add $14.50 more and you get $43.50. So all that information let us know we could divide. So we divided $14.50 by 2, and we got $7.25. So the cost of 1 box of paper is $7.25. So number 9. So this problem tells us we see a table that shows a proportional relationship. I put that in a rectangle because it's very important. A proportional relationship. We know what a proportional relationship looks like on a graph. What are the 2 things we need when we're looking at a graph to show a proportional relationship?
It has to be in a straight line.
The first thing, it has to be in a straight line, and
It has to be 0, 0.
it has to go through 0, 0, right? The point of origin. So when we're looking at a graph to show a proportional relationship, it's a straight line that goes through the point of origin 0, 0. Of course, here we don't have a graph, but we have a table. So, to further the idea that this is a proportional relationship, the first thing we see is that as we have an x value of 0, we have a y value of 0. So that is our point of origin. It goes through. We also see that every time, if we're looking at our x values, we go up 5 every time. 0 plus 5 is 5, 5 plus 5 is 10, etc. Every time that we're going up 5 on our x values, we're going down 1 on our y values. So x, if we start at 0, up 5, y goes down 1. Up 5 more, y goes down 1. Up 5 more, y goes down 1. So that's another clue that shows us this is a proportional relationship. Now our task is to find the equation that describes the relationship. So basically what you need to do here is for each one of these, simply plug in x. Plug in x, calculate the equation, and find the y value. If the y value matches up, then it works. If it doesn't, then it doesn't work. So the first thing I would do is let's check D. Okay, check the ones that look a little simpler first, and then we'll see. So quickly we can tell if we plug in an x value of 0, like up here, our x value of 0, if we plug it in for D, what's 0 minus 24?
24.
Not 24,
-24.
negative 24, right? 0 minus 24 is negative 24. Is negative 24 what shows up in our y value for an x value of 0? No. So we immediately know we can cross that out. Let's try C. Plug in the x value of 0 again. 0 minus 6 is what?
-6.
Negative 6. Does that show up in our y value? It does not. So cross that one out. Immediately, within 30 seconds, we've crossed out 2 potential choices. So now we have to think about the other 2. If I have a coefficient next to a variable, what is that telling me that I'm supposed to do here? Of the 4 operations,
Multiply.
we're supposed to multiply, right? So negative 5 times x. A would be negative 1/5 times x. So let's go through and look at B. Let's plug in an x value of 0. Negative 5 times 0 is what?
0.
0. Does that show up in our table?
Yes.
It does, okay? So when it does show up on your table, you need to check at least 1 or 2 more. Okay, so check at least 1 or 2 more x values. Let's check, since we know the x value of 0 works, let's check the x value of 5. Negative 5 times 5 is what? Negative 5 times 5.
-25.
Negative 25. Does that show up in our y value for an x value of 5?
No.
It does not. So we know that that's not correct. Lastly, we want to make sure that this is correct. Okay? So again, plug in an x value of 0. Negative 1/5 times 0 is what? 0. Anything times 0 is 0. That shows up in our table. Let's look at an x value of 5 because we saw x value of 0 works, so we need to check at least 1 or 2 more. Negative 1/5 times 5. Let's write that out. Y equals negative 1/5 times 5. Okay, essentially we're multiplying fractions here. Okay, when we have a whole number and we're multiplying fractions, what can we do to the whole number to help us multiply? Huh?
Put it over 1.
Put it over 1. Okay, so since we have a 5 here, let's put it over 1. Because 5 over 1 is the same thing as 5. Now we can just multiply across. Or we could do factor bubbles, right? We could do what are the factor bubbles? We could just make 5 over 5 what? 1, right? Divide by 5 on both sides. Make these 1. Negative 1 times 1.
1.
Negative 1 times 1
Negative 1.
is negative 1. Negative 1 over 1 is simply negative 1. Does that show up in our table? It does. Okay, so we know this one's good to go. In other words, negative 1/5, right here, negative 1/5 times x would be the same thing as taking that x value and dividing it by negative 5. Okay, so let's take the x value of 5. What's 5 divided by negative 5?
Negative.
We're dividing. Negative what? Negative 1. Okay, 5 divided by negative 5 is negative 1. What's 10 divided by negative 5?
Negative 2.
Negative 2. Okay, and again, 15 divided by negative 5.
Negative 3.
Negative 3, and 20 divided by negative 5. Okay, so we've quickly figured that out. When you guys have a fraction as a coefficient, okay, you can also just divide it. So like we did, negative 1/5 times 5. Since it's a fraction as a coefficient, we could just say 5 divided by negative 5. Okay, it's the same thing. Long story short, our answer is A. Alright, let's go to question 10. So question 10 is a good question. You'll see multiple questions like these on the CASP. Okay, they give you a graph, and they tell you the relationship between the number of boxes of cereal purchased, which is the X, or our input, which axis is our x-axis, horizontal or vertical? Horizontal. You could also look right here. Every graph is going to have this. You're going to have an X here, so they show you the x-axis. Look up here. There's the Y value. The Y variable. So we have Y-axis. Okay, Y-axis is vertical. X-axis is horizontal. Now, X-axis shows us cereal purchased, and Y value shows us total cost. Alright? Our task is determine if the statements about the graph are true or false. And if you guys were doing this on the computer, you would drag and drop true or false next to each statement. Okay, so let's look at statement number 1. Point A represents the total cost when 6 boxes of cereal are purchased. Okay? When 6 boxes of cereal are purchased. Point A. So first of all, we want to find point A. Here's point A. Perfect. So now we need to see, does that represent the total cost? Again, total cost, will it be shown on the x-axis or the y-axis? The y-axis. It tells us that originally in the problem. Total cost, y, is on the y-axis. Okay? Now, number of boxes will be on the x-axis. So let's just look at where 6 is. 6 boxes. Here's 6. We go straight up to A. So is that true or false that A is giving us the total cost for 6 boxes of cereal?
True.
That is true. Okay? Simply, look where A is. Go down to the number of boxes. We see it's 6. And we can easily go horizontal from A and see that that's $15 for 6 boxes. So yes, it is true. Number 2. Pay attention to the wording. The total cost is $8 when 20 boxes of cereal are purchased. So the first thing you want to do is look at the X value. Do we see an X value of 20 boxes on our graph? Do we see 20 boxes? We don't. Okay?
Tell me.
If we have 8 boxes, what would our cost be? 8 boxes, what's our cost?
$20.
20. So is this statement true or false? False. If they just switch the numbers, the statement would then be what? It'd be true, right? And the last one, the total cost is $2.50 when 1 box of cereal is purchased. The simple way to do this is to find a point that they already gave us. They gave us $15 for 6.
Tell me.
Divide 15 divided by 6. If we did that, we would get $2.50. That is a true statement. Another way you can do it really quickly is look at where the number 1 is for 1 box. Go straight up. It's halfway between 0 and 5, telling us it's $2.50. All right? Thank you.